I can
screaming
see
and stuff like that.
wanting to see you get scared being something as a.
And we respect you for it. It's okay. It's okay. Personally,
You guys watch Black Mirror?
oh
I've seen
my
I've seen some of
gosh.
those. I haven't seen.
My boyfriend loves that, and I hate stuff like that. And the last season that we watched, like the last season was so like gory and like murdery, and I was like, I see so much blood. And
My boyfriend, same way, has seen all of them. And he's kind of just the one who takes the controller when we're in my room and puts on Netflix and then scrolls through Netflix and says, Black Mirror. I'm like, okay, sure.
Because some of them are like really like I think are cool and like good creepy, but like I feel like the ones that we were watching were all just like so.
No, some of them are very disturbing. I personally just finished the Jane is Awful one. I don't know if you've seen that one.
Oh yeah,
That one's kind of mind fucking.
yeah.
But-
I liked that one because it wasn't like murdery.
No.
There was one that was like, what is it? It was like they went to like this tiny little island, like the girl and her boyfriend. And they found out like his parents were like murderers in the 80s or whatever. Yeah, I don't know. It was insane.
One of the first ones that my boyfriend showed me was like you get a text message on your phone, and it's people who have done very bad things, and you have to do what the text message says. You have to go rob a bank, or you have to do X, Y, and Z. And then the last two people who were standing, they had to, you know, kill each other, but not before they found out what the other person did. And one of them did some very not cool things regarding children.
Oh geez.
Yeah. And it wasn't until, you know, the last 10 minutes of the episode when you found that out and you were like, oh.
It's like who writes this stuff?
Somebody's really sick, whoever wrote these.
Is it a horizontal line or a vertical line?
Vertical.
Vertical. So I'll do horizontal. I'll show you how to do this. So let's see. So horizontal line that intersect. So this is like T naught I. So this is fixed. This will be our parameter, and let's just let T be a real number. We might we're probably gonna run into some barf, but that's okay. And when I say barf, I just mean undefined tangents and stuff. But
Is that E to the 2
e
I?
to the 2iz
Absolutely.
on top and bottom, and then a minus I multiplier.
Beautiful.
Indeed. So I think that hopefully yours is maybe easier than this. I'm not sure what's going to happen, but let's just see what happens. That's all we can do, right? So, oh gosh, I'm not sure which of these is. This might be a little nicer to work with. Let's take a look at that. So if this is f of z and f of c, the image, the output, I'm going to go to that and then just see what happens. E to the 2i, and then plug in t plus t naught I, minus 1 over e to the 2i, t plus t naught I, plus 1, and then, you know, just kind of start working through here and see what happens. So we've got minus I, and then e to the 2it. So notice I'm going to get a nice real part out in front, and that's going to be e to the negative 2t naught, because the I squareds. And then e to the 2ti, which is some cos and sine stuff. And here's our magnitude out in front. Notice how the magnitude is totally controlled by the fixed value. I don't know if that's going to, you know, help us, but I'm noting these things as I go through. And then this is the same down here. Yeah, 2t and plus 1. Okay. Well, that is intense. That's intense. Oh my God. Well, we got a division there, so I guess I'm going to multiply by the conjugate of the denominator, just so I can get a constant down here. So I'm going to try that. So the conjugate of this is just e to the negative 2ti. So I'm going to multiply top and bottom by e to the negative 2t naught, e to the negative 2ti, -1. Yeah. Because that's, hold on, I just gotta think about that. Yep, that sounds right. And then the conjugate at the bottom, same thing. Or, this is the conjugate at the bottom. Oh, then that should be plus. That's it, okay. This will be part of the real, and it won't change sign, because only the imaginary part does. And then we go to TI. Yes, +1. Okay, there you go, dude. All right, so let's FOIL. Let's see what we got. -I. And then they got some nice foiling going on in the top. The O and the I are gonna drop out there. Is that? Nah, not really. So first times first is e to the -4t naught. I'm just gonna multiply this times that and that times that. So oh, that's cool, right? Because then those cancel, that just becomes a 1. This times that is just 1. So that's not too bad. And then, so that's first times first, and then outer. I wouldn't write any of this down yet, by the way, because I don't know the answer here. And honestly, it's starting to look pretty hairy, so I'm kind of thinking that the way they gave it to you all is probably the easier route. But then that's first, it's outer. And then inner, and then last, yay. Okay, and then at the bottom, e to the -4t naught, again, these die off, and then first times first is done. Now outer, inner, plus. And then last. My God. What a nightmare. Right?
I don't love it.
I don't love it either. I don't really like it at all. I think it's terrible. Because when I look at that, I mean, I don't see anything happening.
No,
Right?
nothing.
Yeah, nothing happening. So what is the line that they ask you to do specifically? Any vertical line? They just
Draw a picture of the images of vertical lines under the sine function. Do the same for the tangent function.
got it.
Yeah.
Hey.
Uh-huh.
So actually, so your computation would be kind of the same. Clearly, I don't care about the filth on this floor. Yeah, why would I? It's just the dirtiest thing on campus. Let's see, do we see anything cool that might happen there? Like, I feel like this and that are gonna be, so when you take a number, a complex number, and you subtract off its complex part, or the conjugate, I mean, you just get twice the imaginary part. So like this times this. So when I add these, the conjugates are gonna, do you see that these two are conjugates of each other? Does that kind of make sense?
Yeah.
Yeah, so when you add a complex to its conjugate, the imaginary part dies off and you've just got twice the real part of that number. And then this, when you subtract off the conjugate, you get twice the imaginary part. So this is equal to 2 imaginary e to the -2t. It's getting kind of sloppy there, but it's just the same thing that's in there. Yeah, yep. So let me just write that and see what happens then. So this is -y e to the -4t naught. Hating it.
Strong word, Dr. G.
It's a true word. It's not really true, I guess. It's just a dramatic thing to say. And this we can figure out. This is actually not too bad. And this isn't gonna, maybe this won't be that bad. Maybe this isn't gonna be too bad. So then this is e to the negative 4 t naught. It's starting to feel a little less horrible to me. Your mileage may vary. What did I put in negative? This should be plus. 2t. Yeah. Plus 1. And then this we can actually compute because this is just cos 2t plus I sine 2t. Same for this. So when you multiply that scalar, that's a real number. When I multiply it by this, it's just on both of these pieces. So this whole thing here is going to be 2e to the negative 2t naught cos 2t. Okay, there's some really good stuff happening, and you probably don't see it yet, but I think you will in a moment. And then this, when I take that times that, it's just that times this again, but now I'm going to grab the imaginary part, so there's no I on that. Remember, that's a real function, so this is just 2e to the negative 2t naught sine of 2t. Let's rewrite what we have. So this is negative I times e to the negative 4t naught plus 2e to the negative 2t naught sine of 2t minus 1 over something very similar. Now, why am I so excited about this? Well, it's because there's no imaginaries floating around in here. This quantity that we're going to have in here is a real number, and the only imaginariness comes from this here. Unless I've horribly fucked this up, but I don't. That's, we've been there together. We've been through a lot together. So, okay, we got that. So this to me it's messy, but it looks like something I could deal with. It looks like something I could put in Desmos, which is where we're gonna go. Like, you're not gonna be able to do this by hand. I mean, this is a nightmare. But Sydney, would you, my friend, pop up some Desmos for us?
Sure will. It's right here.
Where did the plus I sine of 2t go?
You're scaring me, Lou. Don't ask questions, it might be wrong. No, where are you asking about?
So you were in the where'd the I sine of 2t go?
Oh, that was, so up here, when I took e to the negative 2t naught times, down here in the bottom, is that what you're asking about?
Yeah.
Let's look here. So when we take the real part of this,
because it's just the real
do you
part.
see? Because
Okay,
I just grabbed,
yeah, sorry, I got confused because you were writing and then I just
fair enough. Yeah, fair enough. So do we have a Desmos, my friend?
I mean, I have Desmos pulled up.
Cool. So what we want to do is type, hold on, let me think, how are we going to plot this? Because this is just a real value. And this is just going to be different multiples of negative. What it looks like, so watch this. This is just a scalar, right? This is just a real number. And sometimes it'll maybe go to infinity, and maybe other times not. Most of the other times not. But it's just a scalar multiple. So I have something like this, a k times I. And this k can be positive or negative. What does that look like? That is some kind of horizontal line. So I'm feeling like tangent might take, what did we do? We did horizontal lines. Horizontal lines to horizontal lines? That doesn't make any sense.
Problem asked for vertical and tangent. you said let's do horizontal.
Yes, I know, that was
So-
all me. I'm not, yeah, that was all me.
Nothing has to make sense here, Dr. T. We're taking your word for it.
Yeah.
Is that a mistake? Sometimes. I mean,
Did I screw anything up? Let's just go through this, because it seems shocking to me. And here's why it's shocking to me. What if T naught was 0? If T naught 0, then I just have tangent of a real number, right? So if this is dead, then literally I'm just looking at tangent of a real number. And we know that tangent of a real number, and this still actually kind of might work out, but tangent of a real number, goes like this, so forth and etc. But this doesn't really give us the option to wiggle. Oh, but I think we're okay, because what I'm doing in my mind is something foul. What I'm doing in my mind is I'm taking the real plane where we have this and conflating it with the imaginary plane. So that, I think we're okay here. I think so. Sydney, my friend, could you? What's that?
She's left.
Sydney. Oh, she's just left. Okay, well she won't mind if I step in. Let's take a look here. So I'm going to plot out T versus that quantity right there, and we'll share this together. I'll share this. I'm sure Sydney will be very happy to share. So I'm going to put X equals, and then I'm going to enter that crazy ass expression. But I'm going to make this squared is this. So if we call this just some const. Okay. So I'm going to type that whole thing out with 2 parameters. I'm going to let one parameter be T naught and the other parameter be the T. And so we're going to have here, and I won't put the negative I because it won't know what to do with that. But we're going to have e to the -4, and we'll call T naught A, -4A. Thank you, Grace. It's good to have you right over my shoulder. Truly great. And then plus, what did I say? 2 E. Thank you. That's great. Thank you. And then sine 2t. Thank you. Yes. So I put it up in the exponent, and that's even worse than what we were seeing here.
It's sine 2t.
Thank you. Sine 2t. Yeah, that's what you're saying, isn't it? And then plus minus 1. Thank you. So that's on top, and then we're going to divide. There it is. There we go. Ooh, not that. I guess I need parens. Hi.
hi.
I kind of
sorry.
just took over. No, I was like speaking to you, and everyone was like, "She's not here, Dr. T."
No, it's okay.
Do you mind if I finish this up real quick?
Crazy, Dr. T.
I want to, and you can probably do this faster, but I want to put this. So I'm just kind of like plotting out that thing that I've got over there. I'm going to put this over itself and then tweak it. So what do I have to tweak? Just put a plus? Is it just a +1?
And then the
And
cosine.
cosine, thank you. So cosine, make that a plus. And I apologize for touching your machine
I
without
don't
asking. And I know you
care,
don't,
Dr. T.
but I still like, think that there's propriety. So let's add sliders for the 2 parameters. And can I have a T slider? Bro,
And we didn't use that.
bruh. Yeah, I'm gonna make that T a B so that it queries me for a slider. There we go. Okay, and one more. There's stuff happening on the right. Okay. Oh, no. Okay, so let's move these. So. Huh. It's just kind of a line bouncing back and forth between those two. So this B represents our T. Yeah, so that just kind of wiggles this around. And honestly, the thing I'm looking at is just the X position on this. Oh. Ooh, I got an idea. I gotta make this a parametric plot. Here we go. So it takes us into, what is my parameter? A, comma, that, close that mofo off. It's just funny little, look at the shape it's tracing out though.
Yeah.
It looks like it, ooh, I thought it was a tangent for a minute. It kind of is, isn't it? Is that, if that's hitting around pi over 2, which is 1.7, we got like some serious tangential action. What's the height? Let's see that. Can I see coordinate value?
He doesn't want you to have a coordinate value.
Oh,
That's how. Ha.
yeah, it's not really. Well, this is, I'm not sure I'm gaining a single lick of insight here. So let me explain to you what I'm trying to figure out, and then maybe this will help in some ways. I'm trying to figure out if we can actually travel this whole length of this line, or if as the t varies, we're just kind of bouncing back and forth here. Okay. I think I'm gonna take this offline and do some work and send you all an email, because I don't think this is helpful. Has anyone actually made any progress on this one? It's a good one, it's hella hard.
I was working on it, but
Yeah, what'd you get, Lou?
I ended up just doing, I don't know, cause I didn't do it with the E, I did it,
Probably smart.
so like I subbed in, cause we're doing vertical lines, I said like x of 0, so just like some fixed x plus iy, and then I put that into the sine over cosine, and then I expanded that with like the addition stuff.
Oh,
But then it got kind of goofy.
Okay, you got
because
me
it just
excited
turned
for a
into
minute.
tangent of x sub 0 plus cotangent of x sub 0. At least I think. I could have messed something up in there.
Wow.
But
That
I was
sounds
like,
pretty
I was
weird.
like, that doesn't sound like anything.
But I like your approach. I want to take a look at it really quick because I think
Okay.
that's a neat idea. Oh, so you went into here and then used the sum of two angles identities?
Yeah.
Well, let's.
Because we did something like that for, that's like the easiest way to do 36, was with a similar idea.
Yes.
So
Yeah.
I was
Yeah.
like, okay.
Absolutely. Okay here. So let's just do that. So we have sine of t plus t naught I. It's worth trying. So then that's sine of t cosine t naught I. This is, I don't know, this has a simplicity to it that's kind of nice compared to that. And then plus cosine of t, sine of t naught I. These cause pain though. At least they're constants, but they're not pretty. We'd have to actually like go to the definition of cosine and sine of an imaginary.
Well, you can use like cosh of t naught, and then
True.
I, yeah.
Right, right, okay. This is starting to feel like at least, it's cos.
Yeah.
Yes. then using those identities, so cos of T naught I is I cosh of?
No, it's just cosh of T. But then sine is I. Sin.
Okay,
Y. Yeah.
so an I comes here.
Yeah.
Cool, that's right, those are great identities, they're very helpful here. So then this is gonna be cos T, same thing, cosh, T naught. What's up? Did you see something?
Yeah, I did something.
Oh my god, I did something helpful. That's cool, it's a good feeling. Okay, multiply by the conjugate. We're probably gonna take Monday for questions work too. Seems like a fair deal. I kinda wanna start on integration, but we gotta get this stuff done first. So multiply by the conjugate and then, yeah, this, you know what, I like this. So on top, we're gonna get, oh fuck, I'm just gonna write it down here so I don't have to write the whole damn thing again. So, conjugate of this is just that with a plus. Neat. This is the first time today I've been excited about this problem. I was just terrified before. This is like, well, just walk into the water and hope nothing bites you. And then there's probably gonna be some sweet identities that we can kick into this. So I'm not gonna do the top first, I'm gonna do the bottom first. Because that's just, and then is anything, God please be good, but you're not, you're gonna be nightmarish. So we have, let's put the T stuff together. I think we can fix that too, and then cos squared of T naught. Oh my god. I'm gonna do, then, so that's real, and then the L's will get us our second part of the real portion, which is cos T sine T. Notice how that's there, and that's there, and then we have hyperbolic sine squared. Oh, sorry, there's a lot of O's, but we can factor out the sine cos, and then we'll have cos squared minus sinh squared, which is 1. That's sweet. Did you keep going with this?
No,
like that?
I like split it in a goofy way, and I was like, oh, I can just do this, but I couldn't do it. But I saw that, and I was like, oh, that looks a lot nicer than what I was gonna do before.
Yeah, it's not too bad, it's not too
No.
bad. And then, so outer is gonna be, I'll just put an I in front here, that's not a T, that's a plus, let me make it tinier and less T-like. So then I've got sine squared T cos, so it kind of is the reverse now, where we're gonna get the actual trig function squared and then the hyperbolics mixed like that. So I'm gonna get cos sinh T naught. Ah, okay, cool. Plus inner is gonna be cos squared. Oh my god. Of T sinh T naught cos T naught. All over that. That isn't pretty. And I don't think there's anything that can be done with it, but let's just put it over here. And then let's simplify. So the top here, I can pull out the sine of T, cosine of T, and I'm left with cos squared minus sinh squared, and you can check me on this, that's 1. Cos squared minus sinh squared is an identity, 1. And then this crap, we'll just call this crap star. So far, I'm liking this much better. And then, oh, fuck yeah, this is good. Oh, you guys, we got it. I think we got it. Plus I, and then pull out the cosh. Look what happens when I pull out the cosh cinch. I'm left with sine squared plus cosine squared, and that's 1 also. So then we're gonna get cosh T naught cinch T naught. That is pretty good compared to where we were. This is good. Okay, so here's what we're gonna do. We're going to Desmos. This is now Desmosizable. And what we're gonna do is we're gonna plot this as a parametric system in the real plane. So in other words, I'm gonna let this be the real part and let this be the imaginary part so that it mimics the complex plane, but we're gonna do a parametric equation in there. Now, I think that I wasn't maybe doing this right. Sydney, my friend, would you please go to Google and type Desmos parametric, and it'll give us an example we can have. I have to do this every single time I do this in Desmos. And we're gonna let X be this, and we're gonna let Y be this other part. Do you got an example? Huzzah, cool. This is, yeah, let me just click on this, I'll just click on this first one. Sorry, I'm not gonna do this on the, oh, wow.
Not the coolest shit ever.
Pretty cool. Not as cool as our shit. Alright, so what do we got there? F, T, G of T. So our F of T is gonna be that first function. And that's gonna be, and we will pass this around so everyone can see the glory that this shall soon be. Sine of T. I'm just so stoked how that canceled all that stuff. It tells you, like when that stuff happens, it's, you know, a sign from Euler. Yeah, from the spirit of Euler. And then on the bottom, we're gonna have, and I can just copy and paste that. So what is this? So it's cos squared, so cos, okay. Cos squared. Good Lord. And then we'll put a parameter, we'll call it AT naught. No, they already have to be here. Yeah, why, well, I already got the T, so how about S? S will be our T naught. We'll add a slide. Because that is definitely a parameter we can change all of this to be. And let's shut this other one down because it's pretty noisy. Alright, so that's F of T. Now let's do, oh wait, I'm not done with the bottom. Thanks. The F of T thing, would you read that to me?
T naught, so we're gonna use like
S again. We're gonna use S. Is that also a T now?
no.
Oh, the first one was a T, thank you. And then this one will be S. Okay.
That's sounds good.
S. Cool, thank you. And then plus, now it's sine squared T. And I won't have to type this again, luckily, because cut and paste. Cinch.
Yeah,
Okay.
square root of x.
Thank you, sir. Beautiful. Okay, okay. So now we're gonna cut and paste this and hack it. Sydney, could you do this one better than me? Could you cut and paste that fraction and put it just right across from G, please? And replace the thing that's there on the others. Yeah, so just replace that sign of AT with that beast. Wunderbar. Oh my god. Okay, all right, stuff is happening. So now we just gotta tweak it so it's actually the top, which is cosh of S Cinch of S. That's how, I don't even know if that's how you say it, but stuff's starting to look legit. Very excited about this. Here I go. Look! It's a circle! We did it! This must be right. This is too nice. So now what happens when I change S? That's the T naught. So these are, hey friends, gentlemen, can you come just check this out real quick? Because we have this. We have this now. So here is this slider, this S is my T naught slider. And watch what happens as I slide it. Okay. So see, we have a circle at negative I. And as we move, then that circle starts to become a line. So right when T naught is 0, it's a circle that's tangent to infinity, so it's just a horizontal line. Now watch what happens as I move this way. And it's actually not centered at 1, is it? Or I. It's a little off from that. So I don't
Well,
know.
if it's a, depends on.
I think it's
how
getting
you-
closer to like the ones, the
'Cause, like-
I, but then it's not.
If
So-
it's like a hyperbolic circle,
That's, yeah,
the center is not. The center might be 1, even though it doesn't look like it.
maybe so. That's true.
My guess is that
So like right now, so like you can see the center kind of moving in. So like the center is like maybe, right? But then the smaller the circle gets. So. Boop. Boop. All right, we've got it. Figure out how to write that out.
Take a picture of what we just did.
Picture, actually, screenshots are great. Do some screenshots, cut and paste them, whatever. Damn, that was fun. Did you get anywhere, were you getting through
Yeah, I
that?
finished it. I
Did-
think.
did you kinda make the same
way.
conclusions?
Yeah, it actually really just flipped the T and the T now.
Oh, okay, cool.
Yeah, that's what it ended up being like.
That is beautiful. Great question, because so much fun. All right, that's question 1. Question 2. Anyway, so whose was that? That was
That was my
Lou's.
That's all I have left.
Well, I wanted to talk about 338, so that's
Kind of this. That's this.
that's this.
Okay, and the first one is just sign, right? It's just sign.
Yes.
It's gonna be a very similar routine. So to do the sign, in fact, to do the sign is gonna be a lot easier because you just have the numerator here. So you're actually, and be careful, friends, because you're also gonna have to tweak your T and T naught are gonna be flipped because this is a horizontal line and you're doing vertical lines. So, I don't know if Sydney can even share us a link. I don't know how to save that, but yeah, who knows. So you're just gonna have T and T naught reversed roles for yours. Otherwise, it's the same. And what I'm suspecting is you're gonna see circles like here or here. I'm suspecting you're gonna see something like that when you switch those. That seems pretty reasonable. So yeah, Sydney, to do this with just sign, life is so good because let's look at what that would look like. You're here. So let's take this a little further and let me show you where to go, and then you'll leave here with a sense of peace, or whatever. Okay. Whatever it is you feel like we're leaving with. Less stress about this. Less midnight frightmares about this stuff. And I'll have to check on that identity. Hey, Lou, do you have that identity in front of you? COS?
Yeah, that's it.
Is this
just
right?
Yeah.
Just like
and then
this?
the
Okay.
Sign is the I symbol.
Got it.
Yeah.
Thank you. So this is, it's so much easier with sign. And then this is going to be your x coordinate in the parametric plot, and this is going to be your y coordinate. And then you're just going to let t vary, and this actually looks like an ellipse, kind of, to me. I think this is going to look something like that, or stretch the other way. Does that sound
I think so.
plausible? Okay.
Why are we whistling in the hallway?
Who was?
Somebody's whistling in the hallway.
Do you want me to stop them? You want me to go knock them out?
That's a little much. Yeah, as they should.
It's like I do that all the time, but when I hear somebody else whistling, I'm like, dude, what are you
The
doing?
audacity.
The audacity. What else should we talk about? We've got more time. Because I feel like this is pretty wrapped up.
Yeah, I think we just fried my brain with that.
Okay, that's fair enough.
That was.
So excitement isn't the same. We're not having the same emotional response to that.
Well, my initial emotional response was, wow, why did I take this class? And then we made progress on it. I was like, oh, no, I get it now.
She's just, this is,
It's just me, yeah. No, this is very much
this
more
is,
brand for
this
me.
is prime Sydney right here.
I think after being my professor for 3.5 years, you get to know that sarcasm and drama is all I
I want to
speak.
say it, I didn't want to say it.
No, that's fine. Let's see what we can do. And then the only one that I haven't done is 3.9.
You want to talk about that?
I don't know, I skipped that one first. I don't remember why I skipped it.
What about you? Anything you want to talk about?
I'm good, we've been basically going over everything that I wanted to talk about.
Awesome, okay. Got you. Well, I haven't. You have a task ahead of you, indeed, yeah.
Could we go over 3.9?
We sure can. Can I see it real quick here?
Yeah.
Oh, which one is it?
It's always.
Okay, cool, thank you. Oh, I like this one. This is a good one. This is a great one. So we've got this A that's less than 1 in modulus. We have a transform that we just need to verify as a Mobius transform. It looks like this. We need to show a couple things. So one is show it's a Mobius transform. Step 2 is find the inverse. And I'm going to give you some tips on some of these things here, Olivia and Sydney. And then show that it maps the unit disk into itself. Thank you. So, to be a Mobius transformation means, here's all you have to check. Has to look like this. Check. And we have to have that be the case. So basically just figure out, just map what's the A, B, C, and D up there. Check that this is the case. If this is the case, it's a Mobius transform. So that's step 1. That goes right here. Step 2, the formula for the inverse, I think, is something you derived. Is that right, for one of the other problems? Yeah. So you're going to have this formula for F inverse of Z based upon this. So like find the general F inverse formula here, which is, I'm going to go out on a limb, but somebody could tell me if this is even remotely. I think it's kind of like that. Is that it? Yeah. And the way I know this is because it's like a matrix, and I just remember the matrix inverse formula for a 2x2, and then to pop that in here. sans the determinant stuff. And so Olivia, just literally take these the things you did up there, plug them in here, and simplify it to show that it's actually this thing here. So f of negative a of z is z plus a over 1 plus a z. Just need to show that.
Yeah, I think I got those. See, I know we talked about that one, but I'm still kind of iffy.
Okay, cool. So to show C, I have a tip on that one. And what we basically want to do, the hardest part of it all. So once you know it's a Mobius transform, it's 1 to 1. We need to show that it maps the disk, the unit disk, onto the unit disk. So we need to show two things. If z is less than 1, then that is less than 1. So if the input is less than 1, the output is less than 1. That shows we map into it. And then we actually have to show the reverse, and you can use the inverse on it. And you also need to show that if z is less than 1, you could maybe think of this as w, because that's in the output space, is less than 1, then that inverse formula, and these are actually like ridiculously similar arguments. That's the inverse. And so that shows that if I pull back from the unit disk, I land inside the unit disk. So what I'm doing here in this top one, just to make this a little clearer, here's my z plane, here's my w plane. First thing I'm showing is that everything inside here, these are supposed to both be the unit disk, even though it doesn't look like it. Everything here lands inside here, and then I need to show that everything I can hit here lands back here, so I'm going to show, again, both the unit disk. And you do that with just these two things. So to do this one here, and there might be a slick argument about the second one. In fact, I'll give you a slick argument on the second one to save you suffering. The thing I would note is that if this thing maps the unit disk into itself, when a is less than 1, the opposite of a still has magnitude less than 1. So it's really just another version of this thing here. Like this is just a tweak from this, where the modulus of this parameter a is still less than 1. So once you show this, you're good to go. Now let's talk about showing this. So I spent a long time suffering with this so that you don't have to. And the tip I gave was multiply both sides by this denominator. Like that. And then we're like going through a string, right? This, if and only, this, if and only, this. Square both sides. The square preserves inequality when both the arguments are positive. This is still true. And then subtract this off. So if I can show this, right, this is if and only if this. If I can show this, which looks horrible, but it's not that bad because we have this cool identity that says that. So I'm going to rewrite this then, and I'm going to leave you to do this work here and like FOIL this stuff out, but you're going to see it turn real pretty. And then conjugates, you can pass the conjugates down in here, and I'll let you do that because that's kind of part of the like thing I want you to do. You will see, you will get something here that is clearly positive. And so then you'll go, oh, that's positive, and these are all if and only if. So if that's positive, then this must be positive, and blah, blah, blah. You got it. Does that sound good?
Yeah.
Sydney, does that sound good? Yeah? It's a plan, right? Pretty good plan. anything else to chat about?
When is the exam gonna be due?
Yeah, that's a great question. I mean, I'd like to have the homework by Monday.
Yeah.
It's been a while. It's been a while. It's a while. So if I could get the homework by Monday, that would be beautiful. When do we need this exam due? You tell me. Figure it out together. I mean, ideally by the end of next week, I feel like. I that doesn't sound crazy, right?
No.
Because I want to move on.
Yeah.
We all want to move on.
That sounds really ominous when you say it like that. We all want to move on.
Well, he's got a point. He's got a point.
Like, yeah, I agree with you, but like.
We need to quit living in the past, Noah, is what I'm saying. Embrace the future. So next, yeah, does this sound good?
Yeah.
So Friday, Friday, I think Labina's already done with the exam, but
She's mostly done, if not already done, yes.
she was done within days.
Yeah. She said, screw the homework. I understand this exam. Here I go.
Exactly. Yeah, the exam's gonna be very refreshing. Who started on the exam?
I've looked at it. I haven't started on it.
I've started on it. Not many of them look that scary.
They're not. Could I
There's a
see,
few
do you have a
scary
printed out copy?
I have a printed out one somewhere.
I could kind of just make some comments on it.
Ah,
Oh, thank you.
understood stuff.
So problem one, find the roots of negative 64. Can you do that almost in your head?
Probably.
Picturing them spread around the complex plane and all that shit.
Yeah.
So that'll just be like, oh, what was that about? That's really easy. And it's like literally the sixth root of negative 64. There is a perfect sixth root of 64.
Nice.
That's why I picked it. So that'll be pretty. Number two is like this stuff we were doing here, but so much easier. Find the image of a line segment under a translation. So I would note, and I'll give this back to you so you can look at what I'm saying too. Yeah, let me come later. Number two, 2b is literally just a linear transformation in the complex plane. It involves a rotation and a shift. That's it. So if you look at this, so the way to think about that part B is not make it painful on yourself. You have a transformation that looks like this, AZ plus B. So this thing right here is a rotate and scale. The imaginary part of it is the rotation, the real part of that is the scaling, or the magnitude of that is the scaling. So in other words, this is gonna scale by the magnitude of A, and it's gonna rotate by the argument of A. That's all that is, and then this is just a translate. So for example, let's do a quick example. If I had f of z was 2z plus 3 minus 2i. What is that doing to the plane? Well, it's scaling everything by a factor of 2. So it's literally just stretching everything by a factor of 2. Stretching it out, so if I had a little square, like a square that looked like this, it scales it by a factor of 2. So that means this becomes 2i. This becomes 2 plus 2i, and this becomes 2. And then I shift it 3 to the right and 2 down. That's it. So pick this up, move it. Done. Luckily yours just has this. What does I do? When you multiply by I, what does it do to things? Like geometrically. What's the scaling?
0.
Well, kind of. It doesn't change it, isn't it? That's what you're saying.
Yeah, the scaling is 1.
1. Yeah.
Yeah, the change is zero.
The change is zero. So a scaling by I doesn't stretch or shrink. It's just pure what? What does multiplication by I do?
Rotation.
It's rotation by what? Yeah, it is. So I is equal to e to the what? Pi over 2I. That tells me that I, multiplication by I, is the same thing as a rotation by pi over 2. Yeah, yeah. I mean, we can see this, right? If I have the number 2 and I multiply it by I, oh my God, I'm at 2I. If I multiply 2I by I, what do I get? -2. Holy shit, that seems like it rotated. Multiply that by I, -2 times I, oh my God, another rotation. So that problem should be pretty chill. The first part of it. And then the second part of it, I asked you to do z cubed. And all you're gonna do is put your parameterization in there. So you're gonna have, just look at your parameterization and cube it and then simplify it and blah, 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 blah. But you can also, what does cubing something do? Let's do this. Let's take a complex number. And if you have this intuition in your head, it will help. So if I take a complex number and I cube it, what does that do to the number?
It cubes r and then multiplies like the angle by 3.
So to cube a complex number is to cube its modulus, its actual distance from 0, and just rotate it 3 times. Its angle increases by 3. So for example, if I was at 1 plus I, what's the argument of 1 plus I? Wait, what? That was almost so quiet I thought Labina was here. 5 over 4, yes sir. Solid. So if I take 1 plus I cubed, what is its modulus?
√2.
Oh yeah, sorry, yes, that's root 2, yes. I was actually thinking, like I was asking a different question than I was thinking. So the modulus is root 2. So what is the modulus of the cubed thing? 2 root 2. It's cube root of 2, or square root of 2 cubed. And then what's my new argument? E to the what? Yep. You're really channeling some Lavina today. It's good. We miss her. This is just 2 root 2, like Lou said, and this is just right over here. Right? So I can kind of wing it from there and see what happens. If you think your thing that I gave you is this, it's a line segment that is exactly at pi over 4. It's aligned on the diagonal. So if you cube it, you can now answer that question without doing a lot of math.
Okay.
That's not Lavina. All right, bye friends. I will be in on Friday with Mabel. And if the weather, if it's not raining, I will be here with Mabel. I'll let you know what tree to bring. In a hoodie. Oh yeah. Yeah, no, all outfits and little things in her hair or whatever hair clips.
How early?
How early?
Yeah.
Oh, I'll probably be here like 10:30 to 1. Is that doable?
Yeah, I have class at 11.
Okay. She's going to be so happy. If you come, just like, Maple will lift your spirits.
I thoroughly look forward to meeting Maple. I've been with
Yes,
Maple in
that's
my
correct.
classes as freshman year. As in, like, I've seen her on my Zoom meetings as freshman year.
That's it. Just pop it in there.
Never gotten on.
Thank you.
Oh my goodness. Freaking office hours.
You got to go to freaking off. You have freaking office hours.